One way to determine if a number is irrational is that we can just punch it into a calculator. So if I punch square root 4 into a calculator, so again, make sure you know how to find your square root button on your calculator. If I put in square root 4, I end up with 2. So this is a whole number, so we know that this is rational. So square root 5, when I punch that into a calculator, I get 2.2360 ... It's not repeating, not terminating, so that means that must be irrational. And then if I put 2 times square root 25, well, 2 is rational, so we don't need to worry about that. We just need to worry about if square root 25 is irrational or not. And when we do this, we end up with 2 times 5. Well, this means that this is rational because they are both rational numbers. Okay, two rational numbers cannot make an irrational number. Now, looking at these, we may not necessarily need to use a calculator if we understand how we can determine if things are rational or irrational. If we are dealing with square roots, what we're looking for are perfect square factors. So 25 is a perfect square factor. That can be taken out of the square root. 4 is a perfect square number, so that can be taken out of the square root. 5 is not a perfect square number, so when we square root that, it's inevitable that we're going to end up with an irrational number. So when we're talking about the cubes, we need to then look for perfect cubes. Okay, so in this case here, I'm just going to use my calculator because I can always use my calculator if I'm not sure. So negative 16, the cube root of negative 16, I end up with negative 2.5198 ... That must be irrational. Okay, although 16 is a perfect square, it is not a perfect cube, so we aren't able to cube root that. Here we end up with square root 8 divided by square root 2. Well, square root 8 is not a perfect square. Square root 2 is not a perfect square, so maybe we're going to end up with an irrational number. But when I actually work that out, so square root 8 divided by square root 2, okay, and I do this all in one calculation. I don't do the decimals for this. My calculator gives me exactly 2. So that means that this must be rational. Now, why is that rational? Well, if we have square roots in division, well, we can do division with radicals. Although division and radicals, square roots, are not the same, they are compatible in that we can apply division within a square root. So we can do 8 divided by 2 within the square root, and then that gives us a 2, which is our rational number. So we're looking at square root 5. Well, that's irrational. Square root 45, that's irrational as well, because that's not a perfect square. But when I actually do this on my calculator again, so square root 5 times square root 45, and again, I don't do the decimals with this, I just use the calculation on my calculator, it gives me exactly 15. So that means that this must be rational. Now, it's possible that two irrational numbers divided or multiplied could possibly give us a rational number. Now, it doesn't always, but it's possible. And it's possible because when we do this multiplication, because square roots and times are compatible, they can be done. Although they're not the same thing, they can be done within each other. So I can do the multiplication within the square root. So in doing that, I get 5 times 45 is 225. 225 is a perfect square, and so that comes out of the square root as a whole number. So this is a property of radicals in irrational numbers. Although they're not radicals are not times or divide, they are compatible with times and divide in that we can divide within the square root and we can multiply within the square root. So how can we determine if the number is irrational or rational without a calculator? Well, for square roots, we look for, I'll put a 2 there, we look for perfect square factors. Okay, for cube roots, we look for perfect cube factors. And if we can find those factors and have no other factors left over, we are really dealing with whole numbers, so we're dealing with rational numbers.